Thank you guys for attending. My name is Chris Price. I'm a Senior BI Consultant with Pragmatic Works. Our talk today is we're really going to focus on the rationalization for big data and how big data fits into your current data warehouse infrastructure. So we'll introduce some of the concepts. We're not going to go real deep into any of the technologies as far as Hive or Pig, although I do have some demos to kind of show you what they're capable of. It looks like a good portion of the people that are here are either not using or not planning to use big data, so hopefully you guys, we can get you thinking about maybe how it fits into your ecosystem, if it does fit at all into your ecosystem. So again, my name is Chris Price. I regularly speak at these types of things as well as community events. I've authored a couple books. Certainly feel free to follow me on Twitter at BlueWaterSQL if you are on Twitter. I have a blog that most of this material is already out on, including the slides for this presentation if you're interested in the slides. And you can feel free to shoot me an email with any questions if we don't get to your question throughout the course of this session. So when we talk about big data, surely you've heard big data. It's one of kind of the hottest buzzwords, particularly for executives and so forth at this point. So when we talk about big data, what we're really talking about is the explosion of the data that's available to us. So as recently as 2000, which it doesn't seem that long ago, but we're talking 13 years, only a quarter of the data that we have now was actually digital. The other data that we dealt with was typically on paper, film, if any of you guys remember, actually microfiche or any of that type of stuff. Or there's other analog types of media as well. IBM actually estimates that 90% of the data created in the last 90% of the data that has been created was actually created within the last 2 years. And we're expecting our data volume to grow 10% every 5 years, which is astronomical if you think about data volume as a whole. The interesting thing about that is 85% of it's coming from new sources, things like smartphones or sensors, sources that just were never an issue even 5-10 years ago. The consumerization of technology has a lot to do with that. We're more connected than ever, and all those devices that connect us are actually generating data, which may be of some use in your organization. So when we talk about big data, we describe big data with the 3 V's, volume, variety, and velocity. Volume obviously has to do with the size of data. Variety is the different types of data, and velocity is how fast that data comes. So if we talk in traditional context, we have data that ranges in volume. It's not typically giant, but this is your payroll, accounts payable, inventory, data out of your CRM. The variety, there's not a whole lot of variety to it, and the velocity isn't. We're not seeing that data real fast. When the web really took hold, we saw an increase both in the size of the data and in the velocity of the data in significant manner. The variety of data also as well, but not to the extent as what we see even now when we're talking big data. With things like clickstream and sensors and all the multimedia and social and stuff like that we're seeing, it's just expanding at an astronomical rate. And our typical technologies just aren't suited to handling this volume of data, particularly when we're talking the enterprise data warehouse and SQL Server and analysis services and so forth. The end game for all this is that big data really is big. It's big both in the context of the challenges it presents for your data warehouse and BI strategy, as well as in money, and money generally drives most organizations. In 2012, I believe this is from Gartner, big data drove $28 billion in IT investment. That's a lot of money, and that's actually expected to grow to $34 billion by 2014. So we're not talking about something that's going to remain a niche industry for very long. Some of the challenges that big data presents, particularly if you haven't worked with this before, certainly volume, things like how do we store that much data on hardware? What are the economics of that? Diversity is a big one, particularly if you're dealing with things like getting data from the web or sensors or user devices or whatever the case may be. And that velocity, how fast do we need to handle that data? If it's real time, that's where a lot of the challenges come in with big data, just because you're getting so much data so fast that the typical way of handling data doesn't work. Even when you consider batch processing data, you know, that could be problematic too, just because a single server may not be able to process that data in a given window. And then user expectations are the big one. So in most environments that I work in, the user expects to be able to click on a report, maybe write a query, and get some data. And when we talk big data, that isn't always practical. So user expectations can be a big challenge. So what drives this presentation is how do we plan for this and how do we integrate that? So our agenda today is to review the Hadoop landscape. That's going to be first and foremost. We're going to go through kind of a simplify what the current BI data warehouse landscape looks like. And this is vastly simplified on purpose, given that we only have an hour today. And then we're going to talk about how Hadoop intersects with your BI and data warehouse, your current BI and data warehouse, and what are some of the tools, techniques, and strategies you can use as you plan going forward. So this is what the Hadoop ecosystem looks like at a glance. So there's a lot of funny names on here, and I'm sure you guys have heard most of them, things like Pig and Hive, MapReduce, which is how we do processing, storage, and so forth. I think this can be overwhelming, particularly if you're just starting to evaluate Hadoop. So while I think it's important to know what's out there, we don't want to spend a whole lot of attention on this. We want to understand what's out there that's applicable and how it's actually going to integrate with what we already have or our current investment. What's driving a lot of the interest, particularly in the Microsoft space, is Hadoop on Windows. And if you haven't heard, there's basically two flavors of this. We have a service called HD Insight, which is offered through Windows Azure. HD Insight is basically Hadoop in the clouds. There's multiple advantages to this that we don't necessarily need to discuss during this presentation as far as Hadoop in the cloud. And it's not specific to Hadoop specifically, it's just specific to being in the cloud. Things like being able to scale up seamlessly, being able to stand up a Hadoop cluster and do your processing and shut it down, being able to use the Azure Storage Vault or Blob Storage and so forth. Now, if you're not interested in doing that in the cloud, you do have the option of doing Hadoop on-premise, which is handled by the Hortonworks data platform. Hortonworks, you can actually go out and download the Hortonworks data platform and stand up a sandbox. It only takes about an hour, maybe an hour and a half to get that stood up on a virtual machine and get that going. So definitely something that you can play with very little investment. So let's take a look at the current landscape. And again, I know this is vastly simplified, but this is to level set for those who don't maybe work with us day in and day out. Obviously, we have our data sources, and these are traditional data sources. These can be your CRM, your ERP, maybe there's some line of business applications or a website that you're pulling data from. We have some sort of data warehouse or data mart, and we do some processing and maybe build some cubes. And then that's actually going to be used to feed all of our consumer applications, whether that's reporting services reports, SharePoint, any Microsoft applications where it's Power Pivot or anything like that. So this is very vanilla, very plain. When we talk about how Hadoop and big data changes that, what we're really talking about is shifts. So now we can actually consider doing new sources of data. Things like processing emails or reading log files or pulling in social media data and sensor data. With Hadoop, what we're actually going to do is we're actually going to do the processing. We're going to allow Hadoop to process that data, and then we're actually going to feed that data into our current data warehouse or our current cubes. So we're not talking about a wholesale replacement at this point. We're actually talking about basically expanding the size of the pie by bringing on new capabilities. We have that ability to push data into Hadoop from our current data warehouse or even a cube, as well as pushing data the opposite way, actually out of Hadoop and into the data warehouse. So let's look at a business scenario on how this all plays together. We're going to go with the basis of sensor data. So maybe we're getting sensor data from some machinery in our factory, or it could be proximity data from a mobile application that we have, whatever the case may be. So, and I'm going to use the different technologies that are available, and I'll explain each of them in some detail, maybe not in great detail, just so you can see how everything pieces together. So we have our sensor data, and it's being generated all over the place. And all my arrows showed up once, but that's okay. So we're going to use Flume or something like Flume to actually move data into our Hadoop cluster. What Flume does is it's essentially, it moves logs for you. So it's one of the technology or projects that's available within Hadoop. Now, you don't have to use Flume. You can use any technology that you want to be able to load data to your Hadoop cluster. You can do things like FTP files. You can use tools that we'll see later on in the presentation, like Azure Copy or AZ Copy if you're using Windows Azure. There's more than one way to skin that proverbial cat as far as getting the data to your cluster, including something called Web HDFS. And what Web HDFS is, and we'll see that, is basically an API that allows us to any application to get data to Hadoop in a relatively straightforward manner. So once we have our data in Hadoop and we're ready to process it, we have a bunch of different techniques that we can process data. We can write MapReduce jobs, which are written in Java. We can write a pig job, which we'll look at what pig does via writing some pig Latin. Once we have done that, what we're seeing most people do is actually storing those results in Hive. And what Hive is basically the data warehouse implementation within Hadoop. So once we've done that processing, we're going to push that data into a Hive table so that it's easily available via an ODBC connector to all of our existing warehouse infrastructure. So we can push data to our data warehouse or to our cube via an SSIS package, for example. Our reporting tools can actually query data directly via that ODBC connection. So you can actually connect to a Hive table via ODBC from Excel or reporting services or whatever the case may be. On the backside, or to push data back into Hadoop, we have a tool like Scoop. And again, all these names kind of start running together, but we're going to walk through each one of these in a little bit more detail once we get past here. Scoop basically allows us to efficiently move data between a relational database and Hadoop. So with just basically a single command line, we can actually kick off a job that will move, say, an entire table from our data warehouse into Hadoop. Likewise, we can actually push data the opposite way. We can actually push data from Hadoop into our data warehouse using that same single command line. There's no need to write any code to do that. So this is obviously all using Hadoop HDFS. If you were doing something like on-prem or maybe using something out on the Amazon Web Service or whatever the case may be. My slides are out of order here. If we're looking at Azure, basically the way this changes is we can actually use the Azure Blob Store. So we can do something like copy our sensor data out to the Azure Blob Store, and now we can actually stand up and tear down a Hadoop cluster to process the data as needed. So it's not necessary to keep or maintain that cluster around all the time. The data will be there when we need it because we're storing it in the Blob Store. And HD Insight natively integrates with the Blob Store, so there's nothing special we need to do to be able to mount that data and actually process it in the same manner. So now that we've kind of given you an overview of the current typical data warehouse landscape and kind of where we see Hadoop and HD Insight fitting in, let's talk about some of those technologies in more detail to kind of get you started on thinking about how this may apply to you and your organization. And I've got it split across 3 different groups here. The first one is enterprise data services. So these are things like Web HDFS, which is a system for loading data to an HDFS file system. Scoop, which is an ETL-like tool, a bulk loading tool. HCatalog, we'll talk about Pig and Hive. We're not going to spend a whole lot of time there. That's not really the focus of this talk, but I do want to just show you a couple demos on that. Oozie is a big one. So a lot of times we don't consider how we're actually going to put all the pieces together. And Oozie is what's going to allow us to actually kind of fit everything together and orchestrate it. So we may have 4 or 5 different moving pieces that need to be orchestrated and occur in a specific pattern. And Oozie is the tool that's going to allow us to do that. And then toward the end, we'll talk about the Azure Blob Storage, which is important if you're looking at HD Insight, and I'll do a brief demo of the Azure Copy tool. We'll talk about Hive ODBC. I've got a demo for that and how that works with the SSIS. It's pretty straightforward if you've done ODBC connections before. And then if we have time, we'll talk about Polybase and what Polybase is. Polybase is an interesting integration between SQL Server and Hadoop that's available. So Web HDFS is where we're going to start. Web HDFS was actually born out of another project called HSCP, and this was something that was built and widely used by Yahoo. It's basically a high-performance, first-class protocol using RESTful web services to load data. It is a complete interface, so we can do things like read, write, and manage files in our Hadoop, in our HDFS file system using a REST interface. It does support authentication, and the important thing here is that it supports data locality. Data locality is a very important concept in Hadoop so that we don't overwhelm any one single server. And we'll look at how that works. So let's look at a simple example here. I've got a request that would, using curl, that would actually be sent to open a specific file. So in a Hadoop cluster, you have a control node that is in control of basically all the worker and storage nodes, and then you can basically have a cluster of those worker and storage nodes that are responsible for storing the data, providing you the data redundancy, and actually doing the work in a massively parallel pattern. So when we actually do this, when we actually use Web HDFS, we're actually going to originally go to the control node, or the name node as it's called. And what that name node is going to do, rather than actually serving up the file, is actually going to do a 307 temporary redirect. And what it's going to redirect you to is to one of the data nodes that contains the file. So that first request that you get is actually, the response is going to be a redirect. Now, once you get that redirect, it'll give you the location, and that's actually, the data node is what's going to serve that file up. So we can very efficiently get files out of, or read files out of HDFS. Now we can do other things as well, and again, it is a fully functioning API. So we can do things like rename file, and we see how that works basically using query string parameters. The OP is the operation, we're telling it to rename. And then we're actually telling it the destination that we want to rename that foobar file to. In this case, we're renaming the file from bar to bar2. The same thing for actually managing more of the directories type stuff. We can actually create a directory. In this case, we're using the makedir command to actually create a directory called foo2. So this is just one of the techniques that you can use. And again, this is built on the REST API. So if you're familiar with software development or with web services, this is one of the more popular techniques for doing web-based access. And it is available by default in Hadoop. So from there, we're actually going to jump and talk about Scoop. And again, Scoop is an ETL-like tool. It's intended to, or it's designed to efficiently move data between Hadoop and a RDBMS. So it supports a bunch of different use cases. Obviously, it can do importing. And the nice thing about the import is you can point it at a single table or tell it to import an entire database. It can do exporting. It can do, it'll actually run an eval, which will look at the query execution. We can merge multiple HDFS data sets with it. So if we're doing something like an incremental load where we're creating a new file every day, we have the built-in ability to easily merge those into multiple smaller files into a larger file. How this works is, again, it is a command line tool, but what it's actually going to do is it's actually going to generate a MapReduce job. In that MapReduce job, without getting too much into MapReduce, we have the ability to control how much work is done in parallel. So we can actually, via parameter, tell Scoop how much we want it to do. So if we've got the capacity to run 6 nodes in parallel, then we can do 4 or 6 nodes in parallel. So we're actually going to jump to a demo now. And I'm going to demo a couple different things and explain them as we go. I'm going to copy the first command and get it running first, and then I'm going to go back and actually explain what it does. Let me make sure I don't have my existing directories. Make sure I delete everything. So the first command, I'm going to copy this, and don't worry about trying to speed read here. I'm going to just get this running because it takes a second, and then I'm going to go back and explain it. You see my highly secure password, so make sure you write that down real quick, and you can keep that. So let's actually go to a different screen here where I can explain what's going on with this first command. So again, this is all a command line. You see behind the scenes here, it's actually generating a MapReduce job and running it. The first command I'm actually working with is an import. And there's only 3 settings that I need to worry about for the most part. This first one is a connect. And what you see here is a connection string to a server. Obviously, we're using JDBC since Hadoop is primarily Java. I'm telling it SQL Server. I'm telling it to use localhost, a database, the AdventureWorks Data Warehouse 24 database, and I'm passing it my username Hadoop and my super secure password. I'm telling it I want to load or import the DIM category product category table, and I'm giving it the target directory that I want to load. So what it's doing is it's behind the scene, it's actually running this MapReduce job. It's generated this MapReduce job, and it's actually going out, pulling the data out of the database and writing it to the file system. We're hoping it doesn't run this for the whole demo, but we'll let it chug for another second here. I'll go on and explain the other commands while we're waiting. So the second command, again, it's the same as the first. The difference, instead of pointing a table here, I can actually write a query. So instead of telling it I want the entire product category table, I can actually craft a query that I want to pull the data out of my data warehouse for. So in this case, I'm only worried about the English product category name and the product subcategory name. And it's actually going to run that query and, again, load the data from the data warehouse back into Hadoop. So this job finished now. Now I can actually go out and look at this job, and let me figure out where I'm putting this data at. Just 1 second here, and I'll show you what that looks like, and then we'll move on. I don't want to have to type this. So I'm going to use a Hadoop file system command, which is called tail, that will basically show me what the data looks like. Oh, and I think it's zeros. I don't remember the format. We'll keep going. I'll show you what it looks like once we actually get it back into the database. So I'm going to run the second command, get it started, and then again we'll jump back over and I'll keep explaining commands. So the second command is actually going to again do an import into Hadoop. The difference is it's using the query. So again, it's going to generate the map reduce job and do its work. So this is one of the easiest tools in Hadoop to work with, and I think I forgot to delete the file, which is why we see the exception being printed out to the screen. Let's try that again. All right, so we're going to let that run. That's actually going to load the file that we're going to actually wind up exporting here shortly. So I mentioned previously that Scoop has the ability to do imports and exports. Exports are actually even easier. So what export allows me to do is, again, using a connection to a SQL server and grabbing a file from HDFS, I can actually push that data back into a table. Now, there are some requirements on that. The table format has to match the file format. So there's not a whole lot of flexibility there, or ways you can override that. I'll demo that as soon as this next job finishes running, but while that's going, we have the ability to do other things. So we haven't talked a whole lot about Hive yet or demo it, but one of the nice things about Scoop is I can actually create Hive tables from it. So once I've kind of mangled my data either from the data warehouse into Hadoop or vice versa, I can actually create a Hive table that directly mimics a table in my data warehouse. So I can actually, using the DIM product category table in my data warehouse, I can easily create a Hive table that's going to exactly mimic that table. And we're not going to, we're going to give it one more second here and see if it runs. It doesn't always run this slow. I'm actually running on a virtual machine that's starving for resources. So it is what it is, unfortunately. We'll circle back to this. It looks like maybe it's finishing. All right, it's finished. Let me run the export here. The export again is going to take the data from Hadoop, and it's actually going to map that into our table. So I have the table out here. I've ran the truncate before we started just to make sure there's nothing there. And we're going to wait on the data. Again, it's simply going to push this data from our Hadoop instance into the database. And we'll come back to that. We'll keep going here. So that's Scoop. So Scoop is an awesome tool for actually allowing you to efficiently move data between your data warehouse and your Hadoop cluster. So some of the other names you've probably heard, and again, this isn't a talk on any of these specific technologies in any depth other than just to introduce it. HCatalog. HCatalog is metadata and table management a tool within Hadoop. What this allows us to do is we can actually define tables that our users are going to interact with. This allows us to abstract away the where and how of data stored. And you'll see some of that in demos where it's basically there's a lot of low-level details that depend on where the data is stored at and how it's accessed and so forth. HCatalog allows us to abstract that away, which basically makes it much more consistent and easy-to-use experience for people that are going to be analyzing the data and doing the work with the data. Pig, I'm sure you guys have all heard about Pig. This is the ETL data transformation scripting tool. When you write Pig code, it's actually called Pig Latin. There are a ton of Java user-defined functions that are all written in Java. LinkedIn and I forget who the other are, a couple of the big contributors. Piggy Bank is part of the distribution, so when you download Pig, you get what's called the piggy bank jar, and that's basically a set of user-defined functions that simplify how you can actually write your scripting. Datafoo is the LinkedIn one. So, and there's a lot of the functions that do things like generate those recommendations that you see on LinkedIn that are a part of the Datafoo library. Hive, again, Hive is probably one of the most discussed parts of the Hadoop services that people from the Microsoft community are excited about. This is your SQL-like interface. So you'll see that the queries we write are very, very similar to the queries you're used to in SQL Server. This is what's going to allow you to do ad hoc queries and do things like data summarization and analysis. And then we have that ODBC connector that we're going to talk about as well. Let's go right back to demos now. And we're going to hope this job finished, and it did. So I can actually load this table up now, and now you see that all that data that we pushed to Hadoop is now back in our database. So again, that was the wrap up of the Scoop demo, so we didn't have to wait on that. Let's clean up some of text pads. And again, all this stuff is available out on my blog. Some of the data sets are dependent, but all the commands are out there, so if you want to review any of them, you certainly can feel free to do that. So we're going to talk pig first. So what you see here is a bunch of pig scripts. Before we talk about using pig to process data, the first thing you have to do is you have to get into the pig application. So once you load that, you'll notice that the prompt command is actually grunt. And we can actually build files here that are actually going to allow us to do your typical ETL work. So the first one I'm going to run is fairly straightforward. I'm going to load, I've got some weather data from Weather Station 2012 that I'm going to load into a variable called log. And so all that's going to do is go out to HDFS and get that data into the log. The first example is, again, very contrived. I'm simply going to filter that. So I'm taking the log and saying I want to limit that to 5 records, and I can easily dump that to the screen using the dump command. So you see the kind of the notion that we're actually writing commands with here. Now again, behind the scenes, and you'll notice the pattern here, what pig is doing is it's actually going out and, again, creating a MapReduce job behind the scenes for you. So it's abstracting away that complexity of MapReduce, giving you an easy way that you can write ETL-type jobs to produce output. This is should take a second here. I'll show you some more advanced type stuff that we can do in pig. Again, I'm using the piggy bank jar in this example. I'll highlight it here because I don't have Zoom it. The 2 functions that I need from the piggy bank jar are the substring function and the replace function. So these are 2 functions that should be, you are probably intimately familiar with if you've done any amount of SSIS or ETL work. Those functions are built into SQL Server, so you don't have to actually include a reference. But for pig, you do have to include a reference. They're not built in. So again, the same thing. I'm going to load up a data file. I'm telling it that this data is actually coming in as a single string. I'm limiting it to the first 150 records. I'm filtering it where the row size are basically the length of the string. That's this B filter. I'm checking the length of the string to make sure that it's greater than 95 characters. And then for each record, I'm basically generating a new set of data where I'm using the trim and substring function and substring and replace functions to actually generate station-specific data. So these are things like the station ID, the latitude, the longitude, and so forth. And I'll show you how this runs. We can actually compile these and run these as scripts. You see it does take a second for this to run through. That was a pretty good sized file. And you see basically all that first job did was dump those to a screen. We can actually dump data to the screen, or we can actually dump them to output files if we were going to do something else with it. So I'm going to just start this, and then we'll jump over to Hive. So again, typical ETL type stuff. We'll let that run. And I've got an error here. All right. We'll come back to that if I have time. So we're actually going to jump over now to a HD Insight instance, and we're going to do a little bit of work in Hive. So again, Hive is the data warehouse tool that we work in Hadoop. I'm using straight sample code that's available when you set up and install HD Insight. So again, easy for you guys to use. The first thing I'm going to do is I've got to start Hive. So when we start Hive, what we're actually working in is called the Hive Query Language, or HQL. And it functions, again, a lot like what you're doing in SQL Server. So we do things like create tables. We can list tables. We load tables with data. And then we can actually write queries to select data from those tables. Now, the difference between SQL Server and Hive is that Hive actually isn't storing any data. Hive, it's all about metadata. So we're actually applying structure to the data after the fact. And you'll see how that works. So the first thing that I'm going to do in Hive is I'm going to create a table. And this is again, straight from the sample data. This is the IIS log table. I list my column names with my data types. They're all string or int at this point. And I tell it how the rows are formatted and delimited, and the termination character and so forth. Again, this is your first key that we're not actually storing data. It's actually going to read the files and project the table structure on top of the files. So this is just going to take a second to run. Maybe more than a second. Or that first Hive when that takes a few seconds, 21 seconds approximately to run. So now I have that table. So now I can do things like use the show tables command, and it's actually going to show me all the tables that exist in Hive. So we notice that there's two tables here, a Hive sample table and an IIS log table. I can actually do something like describe IIS log, and it's actually going to spit back the table structure to me. So it's actually spit back all the columns, log date, log time, so forth. So that's interesting in and of itself. But the more interesting thing is now let's load some data into that table. I've got a file out here, and I'll copy this first to show you the file. And let's quit out of Hive real quick. Oh, not quite. Quit. Didn't like that. So what I'm going to do is I'm going to show you, we have out here on Hadoop, or on HDFS, we have a file already. So this file exists independently of Hive. And what it is basically log data. So I'm using the tail command to just basically preview the file as it exists out in HDFS. So if I get back into Hive here, I'm actually going to load that file into the IIS log. Now, when it says load, it's not actually putting the data in the table per se. Again, we're applying the data, the table schema to the data. So it took just 2.7 seconds to actually move to actually move the data. Now I can actually do things like I can query that data. So that was a text file just a second ago. I can actually write a query, again, select everything from IIS log, but I'm going to do the limit 10, so that's the equivalent to the top 10, and it will quickly spit back the top 10 records. Now we can do some other interesting things within Hive. We can actually write output files. So I've got a statement here that I'm a select statement that's basically going to calculate the time taken for each web page, the average time taken on each web page. But instead of printing it to the screen, it's actually going to write it back to an HDFS output file. So again, in Hive, I'm going to paste my commands in there. And it's actually, again, a common theme here. It's going to create that map-reduce job. It's going to do the select, and it's going to write the results of that job out to HDFS. Now, the other interesting thing is now that we have this table out in Hive, we can actually connect to it via Excel and SSIS or any tool that can work with ODBC. So let's take a look at how that works. I have an SSIS package here. First off, you need the Hive ODBC connection for this to work, and you can download that and install that. It's pretty straightforward. We set up our Hive data source, and when we do that, all we're specifying at this point is the name of our HD Insight instance or the path. So once we've done that, put in our name and password, which doesn't really need to be saved. Our Hive ODBC connection is ready and available to go. Now I can do something like add a Hive connection manager. A tip here, it's actually, I work with the ADO.NET connection, and then I change my provider to the ODBC data provider. I select Hive, I put in my password, I can test my connection. Now it's going to actually go out to my HD Insight cluster, which just happens to be in Northern Europe, so I'm sure there's no latency at all happening there. And I have my connection. So now I can do something like this. I can actually build a data flow. And it's validating metadata, which is slow. I can use the ADO.NET source. And again, this is the same command that I used to generate that output file. So it's just a select statement. It's going to calculate the random time taken. We're not worried so much about query syntax at this point. And I'm going to get two columns back. I'm going to get the URL and the time taken. So if I actually execute that, it's going to use the ODBC driver. It's going to connect out to my HD Insight cluster. It's going to execute that Hive query, and it's going to spit the results back. Now, this is going to take a minute, so we'll jump back over to our presentation while this thing runs. Now, this is an important part because this is one of the big misconceptions, particularly if you're not familiar with Hadoop or big data. This isn't interactive in the same way that you're probably used to working with interactive in the server environment. Things take time. This is a batch processing environment versus something where you're actually going to be able to issue a query and get an instant response. Typically what we see is at a minimum 30 seconds to a minute in batch response. So this isn't something that you're going to launch from a web page and then serve within a grid typically. At least not without staging it somewhere else, like say a SQL Server table or something to that effect. Oh, there we go. So it popped back up. So it took a minute or two, but you see the results we got back from Hive are a list of URLs and the average time taken on each URL. So that's our Hive ODBC connection. Let's get back here. So Oozie is probably one of the critical pieces. So it's not a great comparison, but what I compare Oozie to for my Microsoft friends is SSIS. So this is what's going to allow us to orchestrate and run multiple jobs in some sort of step pattern. So this is our scalable, reliable, extensive workflow management system job scheduler. That's straight from the Apache website. The key here is that this is our workflows. And we have a couple of different ways that we can trigger these workflows. They can either be time-based, so something like setting up a job in SQL Agent, or based on data availability, so a file is added to HDFS. The nice thing is that we can run and orchestrate multiple different jobs. So we can run a MapReduce job, whether it's a true MapReduce or whether it's a streaming MapReduce job. We can run Hive jobs, we can run Pig jobs, and we can make them all run together. So maybe we need a MapReduce job to run first, and then we have 2 different Pig jobs run and then a Hive job. So we can actually orchestrate those into a single workflow and have that kicked off by either time or data availability. I don't have a demo for that, but it is one of the key parts, particularly as you start setting up Hadoop. So we're going to spend the last few minutes of time before we open it up for questions to just briefly go through Azure Blob Storage. If you're not sure of what Blob Storage is, it's basically data storage in the cloud. You may also see it called the Azure Storage Vault, or ASV. It's a scalable, persistent, built-in storage option or service that has built-in geo-replication. So it easily allows us to do a lot of the things that we try and accomplish internally with something like a SAN. The nice thing is that your HD Insight clusters are automatically wired to work with this service. So there's nothing you need to do to make this work. If you are doing on-premise via the Horton DataWorks platform, that still uses HDFS, so probably not as relevant. What the blob storage, the power the blob storage gives us is that it allows us to separate the data from the compute nodes, and that's very important from a cost perspective. When we're working with working in the cloud, typically from a cluster perspective, what we're looking at is compute time, and that's basically how you determine your cost. So whatever the compute time is, that's what you're going to pay. So you don't want to keep clusters hanging around when you're not actually processing data. So the idea is that we can actually stand the cluster up, do the processing work, and then shut the cluster down. That only works if we don't have to constantly move data around. And what Azure Blob Storage does is allow us to have that data available so that when that cluster is created, the data is there, we can process it, and then we can drop it, and the data lives on. The other nice thing about the Azure Blob Storage is that multiple clusters can share the same data. So we may dump all of our internet logs or our sensor logs to the Blob Storage, and we can have multiple different clusters that are accessing that same data. The thing that makes this whole process work is what's called the flat mesh grid network. This is a very, very high performance network. Some argue that it does violate the principle of data locality, which basically means that the data is local to whatever job is processing it. But the tests that I've seen, it almost always outperforms HDFS and the different competitors that are out there as far as Amazon and so forth. So this is what it looks like if you're actually working with, and I've got a link up here to Denny Lee's blog if you're interested in getting more of the nitty-gritty on how this works. So we have our compute nodes. They're actually going to stream data from the blob storage to the compute node. And once it does that once, the data is actually held in the flat network storage so that we don't have to go all the way back to blob storage while we're processing. And that's really where you get the performance lift. Pushing it back is you see illustrated here, typically done for you. When you decide to work with the Azure Blob Storage, one of the concerns is, how do I get my data out there? It can seem kind of daunting, particularly if you have a lot of data to get out there. One of the tools that's available, and it's certainly not the only tool out there, but out there on CodePlex called Azure Copy. And what it basically allows us to do is easily copy files to or from the Azure Blob Storage. You see the command line here. It functions very much like RoboCopy. You give it the name of your container, you give it your key, and then you can specify a couple flags. We can tell it to recursively copy all files in the directory, and then do things like do verbose logging. Now, this is a command line, so this is something that you could orchestrate via a SQL agent job or an SSIS package or something like that. So let's look at this one final demo before we wrap up. So I have a set of files here, and one second here. I have to get my demo text pad that got closed. I've got, again, this is a command line. That's also a theme for today. We're going to open up a command prompt, and I have to go to where my Azure Copy executable lives, and I'm basically going to put in the command line. So again, I'm simply giving it a directory path, giving it a container, giving it my destination key, and telling it I want to recursively copy all the files in there. Now, it may take a minute. I'm in a hotel room with free wireless access, so I'm sure my connection is not as high speed as it would be if you were in an enterprise scenario. It's going to connect out to the container, and it's going to actually do this work in parallel for you. So it takes care of doing some parallel uploading, assuming it can actually connect. And it does not like my container name. So we're actually running out of time. You're just going to trust me that that worked if you had it configured correctly. I've got the wrong container name. I thought I left that container out there, but I must have deleted it. So we'll carry on. I want to leave a few minutes for questions. Polybase, we're going to fly through Polybase. So Polybase is, if my screen will refresh. All right, just work with this way. Polybase is part of the Parallel Data Warehouse, and this is the technology that's going to allow you to integrate your relational and non-relational data. Non-relational data is typically what we refer to as big data. This allows us to create external tables via a bridge that's created with HDFS. And what this allows us to do is basically create on-the-fly joins between something like a Hive table and a table that's on our Parallel Data Warehouse. Obviously, this supports a lot of things in parallel, both imports of data to HDFS as well as exporting data from HDFS. There's a lot more that you can read up on about this. It's more just to introduce you to what's available out there. Finally, the last slide here is a bunch of different links and resources that I have available, places you can actually go read up and get some more information on this stuff if maybe your brain has started churning and you think there's a way that this applies to your architecture. If not, we will go ahead and open it up for questions.
Okay, great. We do have a few questions. So the first one is, can we use SSIS instead of Scoop?
The short answer is yes and no. You can use SSIS to move data, but at some point you have to get the data into HDFS. So you may be doing that through the REST, the Web HDFS API. There is actually a white paper out on Microsoft called Integrating SSIS with Hadoop, and that may not be the official name, but if you Google it or Bing it, there's a whole white paper that's written by the Microsoft team that talks about how you can use SSIS to interact with Hadoop.
Great. Our next question is, which data types are supported by Scoop, and how does it convert SQL Server data types to Hadoop data types?
Internally, I don't know how it actually handles that conversion. It does the mapping for you so that you don't have to worry about about doing the data type conversions. I'm not sure the level that it supports data types, so I don't know if it supports the different variation of date times or so forth, or if it just converts it to a string. It's fairly robust in how it works, particularly on the import, because it's basically just writing text files, so it doesn't really care about the data format coming in. The export, I would probably need to dig into that a little bit more to get an answer for you.
Okay, great. Are the tools that you showed free open source?
Yes. Every tool that I showed is free and open source. Every tool that I showed, except for Polybase, which is applicable to PDW, is a Apache top-level project. So it's an Apache top-level project. There are multiple vendors out there like Cloudera and Hortonworks that you can actually go out and download their sandbox, which is a virtual machine image, stand it up, and be working with this almost instantly. The same for in the cloud. Both Amazon and, of course, HD Insight. You can stand up clusters in the cloud and be working with all of this stuff with little to no money out of pocket.
Great. Can Uzi be managed by enterprise scheduler tools?
Yes, to some degree. So keep in mind, as you saw through most of the demo, we're executing command lines, executing scripts, and so forth. So as long as you have the ability to go out to a specific server and execute a command line via your workflow scheduler, then yeah, you can use an existing workflow scheduler. And again, that white paper on SSIS and Hadoop integration talks a lot about that. A lot of what they talk about within that white paper is actually using the execute task, which is simply just executing executables.
Okay. Do you think that Hadoop technology can replace the need of a traditional data warehouse?
I think with some planning it could replace. I don't know what the value proposition of that would be. So you certainly hear that discussion, and it's pushed in large part by a lot of the big data vendors that, yes, it certainly could fill the role of an enterprise data warehouse. But if you've already invested in a data warehouse, I don't know that you would get any added value by doing that. You would, in my own opinion, you would be doing it just to do it. I don't know that there's the value to swap it out, but it certainly could. I don't know that makes sense.
Okay, great. Our next question is, how do you recommend a regular SQL Server guy get started with Hadoop? Is there an easy way to set up a learning environment?
Yes. What I would recommend, and again, in the cloud, working in the cloud is the easiest way. I believe there is a free trial period for Azure that you can actually go through and get some free compute hours. That's one way of doing it.
Yep.
Be aware that at some point you are going to incur some costs with that, but it's very trivial. Just to give you an idea, I unintentionally left the Hadoop cluster running for about 5 or 6 days straight, and my total bill was about $30. So it's very, very cheap, even if you do incur costs. The other option is you can use a virtual machine. So you can use something like VirtualBox or Hyper-V or VMware and stand up a virtual machine and go out and download one of the sandboxes. So Hortonworks has a developer sandbox. That's a virtual machine image that you download, you plug it in, and it's all set up and ready to go. Same for Cloudera. Both of those are on Linux, so you'll have to account for that. The third option is you can download the Hortonworks data platform for free from Hortonworks. You can set up a Windows VM and actually install that on a Windows VM. And from soup to nuts to stand up that VM, including the Windows install time, which is the bulk of it, it's maybe an hour and a half to get that up and going.
Oh, that's not bad. Okay, our next question is, do we need to use Scoop to move files from ASV to HD Insight?
No. So Scoop is not needed if you're working with Blob Storage. So again, if you're working with HD Insight, it's basically built-in integration. So you're already connected to your containers out on ASV. So there's no need to move data at all.
Okay. Do the tools you showed only support SQL 2012?
No, they support, again, the tools, particularly the integration for Scoop, it's using the JDBC SQL Server driver. So it'll work with 2005, 2008, so forth. I just happen to have 2012 on my install. Coming back the other way, it's an ODBC connection. So anything that supports an ODBC connection will work.
Okay. Can we integrate Hadoop with the .NET or vice versa?
Yes. So there are some libraries out there. I believe Microsoft has released some libraries for doing streaming MapReduce jobs via .NET. There are some other APIs that allow you to interact via .NET with Hadoop. It's certainly not as robust as what's available via Java, but again, it's still relatively new. So I would expect that that's an area where they would continue to grow.
Okay. Our next question is, can Hive queries be optimized via hints or anything else?
Yes, Hive queries can be optimized. So I believe toward the end of October, I'm doing another presentation that's going to dig into a lot of that. So you can do things like build indexes in Hive. You can do partitioning in Hive, a form of bucketing and so forth that more deals with the actual structure. But there are some performance tuning things that you can do to make your Hive queries run faster.
Okay, and unfortunately we only have time for one more question, everyone. I will pull this report and send it to Chris so that he can respond via blog post. Our last question is, do we have any sophisticated IDEs for Hive or Pig available in the market?
That are open source and free, no. There are some pretty slick web-based interfaces for managing Hadoop and interacting with Hive. There is a web interface that's part of HD Insight, but I wouldn't call it. It's nowhere near what you're probably used to working in Visual Studio. I just don't think it's there yet right now.
Okay, well, thank you very much, Chris. That was a great session.